Hi, I'm Dennis. I'm 35 years old and I'm from Brazil. And this is the assignment for week 1 of the Introduction to Musical Production online course hosted at Coursera.org. So in this video, I'm going to talk about the two first basic audio properties, which are propagation and amplitude. For the sake of brevity, I'll omit the two other properties, which are frequency and timbre, but there they are listed just so you know that they exist. I'm also going to show how amplitude is shown visually through the aid of computer software. In this case, it's going to be the Voce Vista vocal analyzing software by Donald Gray Miller, and you can read more about it at the vocevista.com website. As you can see, this software has an oscilloscope view where you can see the sound waveform. It has a spectrogram view, and it also has a spectrum analysis tool. Okay, let's talk about propagation. And propagation is sound moving through a medium. It could be air, it could be water, it could be a metal. We're primarily focused on air since that's the medium through which sound reaches our ears. It's measured in speed, which is distance over time, and the speed of sound through air is roughly 340 meters per second, or 1 kilometer every 3 seconds, or 1 mile every 5 seconds. There are things that change this precise measurement, like temperature or pressure, but roughly that's it. Okay, so sound is energy, and it moves through the air in waves. And these waves are said to be longitudinal waves because the direction in which the waves move in is the same direction of the vibration of the sound source. In contrast to that, we have transverse waves, which is like an object falling into the surface of water, where the object falls and the waves produced are produced at an angle to the direction of the falling object. And the last thing I want to say about propagation is that it creates a sense of space because sound gets to one ear before it gets to the other, so it gets to the left ear before it gets to the right ear, and then we perceive that as sound coming from the left or coming from the right, or even coming from back to front, because our ears are fine-tuned to do that kind of analysis. Okay, let's move on to amplitude, which is the extent of the wave, or more formally, the difference between a peak and a depression in this sine wave representation of wave, which is the point of maximum energy and the point of minimum energy in the wave. This maximum in the case of a sound wave would be the point at which the air is most compressed, and this depression would be where the air is more rarefied or less compressed. And then following this depression, we'd have another peak and another depression, and then so on. So let's go ahead and use Voce Vista to try to visualize the changes in amplitude. So I'll make a quiet sound like this, and a loud sound like this, ah. And you can see that a loud sound has a larger amplitude than the quiet sound. This change is also shown in the spectrogram. The hotter colors are higher amplitudes, and the colder colors, like the blue, are quieter sounds. Now, amplitude is measured in decibels, which is a way to measure sound wave energy, and more energy equals more decibels and is perceived as louder sound. There are two different decibel systems we need to acknowledge. The first is dBSPL, which is used in the air and stands for sound pressure level, in which the 0 represents the quietest point, and then you progress upwards until we get louder and louder until the threshold of hearing. Now in digital gear, we use the dBFS system, which is the full scale system, in which 0 represents the loudest point or the loudest sound possible, and then we progress negatively until we get quieter and quieter. So that's it. I hope you enjoyed the video. Thanks for watching, and good luck on your studies.